You'll see. So we're at this point with two triangles, yes? All right, and then they said to themselves, okay, we got to do some work with this. So then they went ahead and they measured. All right, so let's say they measured this side, and they measured it to be 35. Everybody cool? And then they measured this side, and they measured it to be 25. Everybody cool? Okay, now what can you do with the green triangle?
Trade.
What kind of trig? Remember, we're looking for Q. What would I do?
Cosine.
Sine, right?
Yeah.
What would you do in the green triangle? Your theta's what? 30. Your opposite is what? Your opposite is Q. And your hypotenuse is 35. Yes? Everybody cool? Okay. So we need Q solved. So Q must equal sine, I lie, yeah. Sine 35 divided by, not sine 35, moron, sine 30 divided by 35, yes? Opposite over hypotenuse. Everybody cool? Okay. You guys are smart young people. What's happening in the purple triangle?
The same thing.
Q equals what?
Sine 50 divided by
Sine
25.
50 divided by 25. Correct? Now, being the intelligent young people that you are, you notice that Q equals this. Correct? And Q equals this. Correct? So what does that tell us? That sine 30 over 35 must equal sine 50 over 25, correct? Everyone agree? Makes perfect sense, doesn't it? Right? Now, you cool? Okay. So now, what they noticed was, okay, well, 50 and sine, what goes with sine? What are the two things that go with sine? Opposite and hypotenuse, yes? So in this equation right here, I have 50, I have sine, and I also have the opposite to 50, don't I? Everybody cool? And I have 30, I have sine, and I have the opposite to 30, don't I? Except they're not together, are they? But watch. What would happen if I told you that this 25 was x? What would go right there? X. Everybody cool? Okay. In that case, how would I solve this? I would do a bunch of algebra, yeah? And eventually what would happen is sine of 50 would be over 35. And the sine of 30 would be over x. Now we know that x is 25, right? So that sets us up to have the angle, the ratio of an angle over its opposite side must equal the sine of that angle over its opposite side, which would then mean in the third one, what would happen? Because there's 3 angles per triangle. What would happen with the third one? It would be the sine of the third angle, which I'll use capital Y for, over the third side, little y. Everybody cool? You can see how it works when you split it in half because of this piece of logic. that has to equal that. Does everybody understand? Because they both equal Q. Once you've set that up, you can move this around to get the 25 with the 30 and the 35 with the 50. Just by doing algebra, right? If you don't see it, I'm willing to do it if you want to. Okay, so I want my opposites to be with signs, yes? So, what would I do to get this? Because 25 is not opposite of 50, is it? How would I move this 25 in algebra? What would I do? I'd multiply this side by 25, correct? So if I multiply this side by 25, what do I got to do over here? Multiply by 25. Everybody cool? Okay. They're gone, right? How do I get rid of this 35? Multiply by 35. They're gone. And over here, I've got multiply by 35, yes? 25 sine 30 equals 35 sine 50. Now I'm together, yes? I've got the opposites where they belong. Everybody cool? Now, pretend that we don't know this side. If I don't know this side, what math? Or what would I put there? Right? This whole thing would be a variable. Right? How would I get this sign alone? What math is happening right there? Multiplication. So how would I get this sign alone if I was just trying to find the angle? I'd have to divide. Then I'd have my 35, and I'd have to divide there, and I'd have my 25. Is everybody cool? All right. Now what that does, and I didn't get you to write it down on purpose, because right over here, when my computer thaws, when my computer responds, right over here, I have the sine law, which is what we just proved. What do we know about the little letters? What are they? Sides. And what do we know about the big letters? They are angles. Now, this is slightly different, right? When we were working with SOHCAHTOA trig, and you can draw a SOHCAHTOA trig over here, A, C, B, lil C, lil A, lil B. The sine of A was lil A over lil C, yeah? Sine of A gave us this fraction, right? We've done this to death, correct? We now know that every angle can be put into a 90-degree triangle, and we can use that to find this fraction, yes? Our calculator makes that a decimal. Yes? And every angle has a decimal. Agreed? Notice that in the sine law, we are going straight to that decimal. All right? It is the sine of the angle. It is this fraction that is going there. Is everybody cool with that? So we draw it out as such. A, B, C, which makes this side what? The bottom. Sorry, my dot didn't move. What's the bottom? Lil A. What's the top or right? Lil C. What's over here? Lil B. And you just do this and you fill in the parts you know. Is everybody cool? Now please notice that to do any one of these, what do I need? I need an angle and a side that are what? Not adjacent. Opposite to each other. So, if I know big A and little a, I can fill this in and that'll allow me to do the rest of it. Right? What if I only know C and C? Then I use that pair. And if I only know B and B, I use that pair. Does everybody understand? Okay? Now, the only other thing you have to be aware of is this situation here. If I give you this, no signs involved, we're just doing algebra. A over 15 equals 12 over 60. Can you solve that? They're solving it algebraically, and then there's the shortcut that always solves fractions. One is doing math, one is knowing what you are doing, right? What would I do to solve this, technically? I need to get A by itself, so what would I do? I would multiply by 15 on both sides, right? 15, 15, yes? Okay, so that is A equals, now what had to happen here? I had to do 12 times 15 all over 60, yes? Now what would I do with that 60? How do I get rid of that 60? I multiply by 60, do I not? Cancel. What has to happen over here? 60. So now I have 60A equals 12 times 15, yes? Now what would I do with 12 times 15? What would I do? I would multiply it, yes, which would get me 180. And then what?
If A equals 12 by 15 over 60, couldn't we get 12 by 15 divided by 60 to get 8?
Yes, that's what I'm going with. That's where I'm going to. What do I need to do now? I need to do all that, which you just said. I need to do this. And then what? Then you divide by 60. Is everybody cool? Now, what did I do? What did I do at the end? I did 12, right? Times 15. And then I divided by 60, correct? Now look back at the original equation. 12 times 15 divided by 60. So every time you see a fraction, what can you do with the diagonal pair? We call it cross multiplying, but that's not really what you're doing, because actually you're dividing at the end. Every math teacher calls it cross multiplying, but that's not what it is. It's actually proportional reasoning. So I do that, and then what do I do with what's left over? I divide it. Now, a lot of math teachers like to give you guys cute little fun ways to remember how to do things. Right? I hate that. But because you people have been raised on math with cute little rhymes and fun little jokes, I sometimes use them. Whenever you have two fractions equaling each other, you do this. You multiply the pair and you divide the spare. There's the pair, because there's numbers in both spots. There's the spare, because he's by himself. And you're left with A. Aight? If you like cute little rhymes, feel free to use them.
Hold on. Why is that 12 over 15 still over 60 if you multiplied it out to get to 8? What are you talking about? You have to pay attention.
Well, we could have stopped right here. We had A by itself. Right? But I wanted to finish the algebra to show you that all you're doing is multiplying 12 times 15 and dividing by 60. If you did all the algebra, this is what you actually did.
Okay, because when if I were to get A equals 12 by 15 over 60, I'd just end it right there.
Well, you would, yes, of course, but you would finish that off because there's no variables in there. 12 times 15 is 180. 180 divided by 60 is 3. A equals 3. Okay? Now, let's put this into practice, shall we? In triangle ABC, so I need a triangle ABC, correct? Do I have a triangle yet? No, draw it. Everybody draw a triangle. Don't label it. Just draw it.
Mine looks so big.
Everybody cool? Okay. Now, A is 40. The way I have drawn this triangle, there's only two possibilities for 40. Yes, where are they?
Down low.
The bottom two, right? All right. So I'm going to make that A and that 40. Which one, logically, should be 75? Okay, so that makes that B and that 75, correct? AB is 6. Where is AB? Right, 6. Right? Which makes this side C, correct? Everyone agree? Okay. I want AC, which is right here. Yeah?
Yeah.
What variable would I give it? Lil B.
W.
What's this? And BC, what variable would I give that? Lil A. Now, let's do some math. Is there anything about this triangle that we know that was not given in the question?
The other angle.
Why do we know the other angle, Luke?
Because triangles always add.
Triangles add up to 180, yeah? So what's 75 and 40 is 115, yes? So this must be 65. Everybody cool? Now, look closely. We know, because we just proved, that we can do trig on any triangle if I have the angle and the opposite side. Do I have that anywhere? Where? I have big C and little c. I know that little c over the sine of big C must equal lil b over sine b, which must equal lil a over sine a. We just proved that, yes? So let's do so. What is lil c? 6. Sine of what? 65. Must equal. Do we know lil b?
No.
No. So it stays lil b. Do we know big B? What is it? Sine 75. Now, do I have a pair and a spare?
Yes, sir.
So, what do I do with my calculator? I do multiply the pair, 6, sine 75, and then what? Divide by sine 65. That will get me B.
That's cool.
Now, what is happening over here? I still have 6 over sine 65, but it also has to equal A over what? Sine 40. What's my pair there? Same pair. Same spare. So what am I going to punch in over here to my calculator? Six sine 40 divided by sine 65 will equal A. Is everybody good? You punch this in. Be careful. What do you have to remember? There and there. What do you have to remember? Brackets, right? Because if you don't remember the brackets, you're going to get a weird number, aren't you? Because your calculator is going to do 6 times sine 75 divided by sine 65. Actually, no, it will not give you the right answer. Or it might. Yeah, okay. Yeah, that one will work. There is, in when we do the cosine law, you have to be careful.
There's more?
Oh, yeah, brother.
But it was 10.
So is everybody cool? So what did you get for B? 6.4. And what did you get for A? 4.3. Now, you guys are intelligent people. Yeah? How would you describe angle B in comparison to angles A and C? It's the biggest, right? How would you describe side little b in comparison to the other two?
Larger.
It's bigger,
It's greater.
right? So what does that tell you? The biggest angle is what? Across? Opposite the biggest side. What would you describe little a and big A as?
Smaller.
The smallest, yes? What does that tell us about the smallest angle and the smallest side?
That is the smallest. Smallest side is always opposite.
Opposite the smallest angle. And what would you say about the middle side and the middle angle?
Medium.
It's the middle one, and it's opposite from the other one. So if you do a bunch of trig and you get a triangle that doesn't work, will you hand it in to me?
No.
No. It's kind of like when you do a bunch of Pythagoras and get one of the legs as longer than the hypotenuse. That can't happen. All right, now, I encroached onto the next blank here.
Oh, I did too.
Okay? This blank was just there to remind you what solving a triangle means. What does solving a triangle mean?
Solving every single thing.
Yeah, all the sides, all the angles. So let's draw the triangle. Again, why am I drawing this triangle?
To get it embedded in the brain.
Is this necessarily the way my final triangle actually would look? No. Why is it there? What? Yeah, it's just a map, right? If I give you a map to Disneyland and you start driving, is it going to be a flat, straight drive to Disneyland? No, you're going to drive through mountains, you're going to drive through deserts, you're going to drive through forests, right? The map is just there as a guide. So what is this triangle here for? A guide. Let us begin. Angle D is 35. Does it really matter where I put angle D?
No.
No? Just to prove it to you, I'm going to put it up here. Even though that's obviously not 35 degrees, is it? So I'm going to make that 35. Everybody cool? What else do we know?
Side E and B.
We know Lil D is 7. Where's Lil D?
Opposite cross angle B.
7. Obviously, this triangle's not drawn correctly, is it?
It's not drawn
Because it says that 12 is one of the other sides. And this should be the longest side. But does it matter? No. So now I've got a little e. Does it matter which one I make little e? No. So if I make that 12, what does that make this? Big E. Which makes this big F and makes that little f. Yes? Everybody cool? That's a stupid way to draw the triangle, isn't it? But what does it give me? Does it give me my pair? Okay. All right. So now it doesn't matter how I draw it because I don't even really need to draw it, do I? Because I see I have big D and little d. So the little d is 7 over the sine of big D, 35. Right? Now, what else do I have? I have little e. I put the sides on top. So what goes on the bottom?
Sine X.
Sine of big E, correct? Right? Can I solve that?
Yeah.
Why?
Sine 35.
Because I got my pair. Where is it? Sine 35 and 12. And what's my spare that I'm dividing by?
7.
7. Be careful here. You're going to screw it up unless you're thinking. What will this operation give me? It will give me sine E. So what do I got to do at the end?
Get the sine of that number. No. Multiply by sine.
Damaris. Inverse sine. Because I am going to get a sine. If I write this out, 12 sine 35 divided by 7 gets me sine E. What do I want? E. So what do I got to remember to do at the end of all of this? shift sine. If you're good with your calculator, it's possible to do it all in one step. Figure it out. Tell me what E is. Go. When everybody has told me what E is, we'll talk about how to do it all in one step.
Cool.
Who has an angle for E? Who has an angle for E? Ironica, what is it? 80. Abso-smurfly correct. Or on your calculator, 79.5, blah, 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 blah. Now, there's tons of ways to do this. You could do it step by step. You could, on your calculator, go, okay, 12 sine 35 equals. That's going to give you a number. I think it gives you 6.88. Then, that's showing on your calculator, you would push divided by 7. No, you need the sign first. So you would do that, 6.88, it's showing on your calculator, divided by 7, then push equals. And that's going to give you like 0.987 or some crap like that. Then you would go shift sine of that. Okay? Now, if you have a forward calculator, it's real easy. I've lost my calculator. What? Restore. Whew, that was close.
What did you do?
I deleted it by accident. If I have my forward calculator, watch. Shift, sine. Right? Now, the first thing I'm going to do is my 12 sine 35. Close the brackets on the sine and close the brackets to keep 12 sine 35 together, yes? Divided by 7. Close brackets again because I'm shift signing all of that. 79.5. Okay? If you're no good at that or you haven't practiced it enough like I have, which is fine, 12 sine 35 equals, there's your answer. Divided by 7 equals, there's your answer. Shift, sine, and then what is possibly going to become your best friend, the answer button on your calculator. ANS if you have it. Shift, ans. The last answer your calculator gave you, which for me is sitting right there. Close brackets, equals 79.5. Is everybody Gouda? Okay. Now I know big E is 80. Correct? The usual is what happened. My computer is a piece of garbage. Oh, there they both are. Over there, right where I drew them. Now, do I have another pair? I do. Can I do this pair yet? Why? Because you know the other angle is what? 65. So now you know big little f over sine 65 equals. Now, should you use 80? You can. Or you can use 7 and sine 35. It doesn't matter which. Okay? If I do 7 and sine 35, do I need a shift sign for that one? No, because I know all my signs. So it's going to be 7 times sine 65 divided by sine 35. And that answer has to be a number between what and what?
12 and 7.
Between 7 and 12. Because 12's across from 80, 7's across from 35. That's the middle size angle. So that must be between 12 and 7. If it isn't, what have you done? Something wrong. Would you hand it in? No. You would go back and check your work. It is 11. Lovely. Everybody cool? Great. You try the next one while my computer thaws. Talk to your neighbor. There should be a next one. Oh, go straight to cosine law? What time is it? 10:07? We'll stop. Because cosine law, it's a bit of a bear.